So the examples we did were kind of real world, but there were also made up real examples. Let me give you an example of an actual real life example where people did hypothesis testing in order to formulate their conclusion. And it turns out that almost everything we do in science is based on this framework of hypothesis testing. In science, we come up with an idea or hypothesis that we're trying to test, and we gather some evidence, some observations, and based on that, we decide whether or not we should reject the hypothesis or continue to hang on to the hypothesis so that we can observe more things and decide later. And basically, that's what science is all about. So, as an example, have you guys heard of the Higgs boson particle? So, back over 10 years ago, maybe around 15 years ago, this was big in the news. So, around the 50s or 60s, there was this famous physicist. His name was Higgs, and he came up with this crazy theory that he proposed that there's this particle that was responsible for generating mass in the universe, generating more mass. And so this particle basically gave rise to more particles and more mass. And so the media got wind of this, and they tried to call it something more provocative. And so they called this the God particle. So back when this physicist first proposed this, it was just an idea. There's no way to be able to test this idea at all. But then later on, when technology became more advanced and we were able to build more sensitive tools and instruments, around 2010, there were countries that proposed to build a detector that would be able to detect whether or not this God particle actually existed. And this was called the Large Hadron Collider. And this was basically a huge tunnel that was miles long, which was able to basically accelerate particles. And it took this tunnel being miles long so that you could have that distance to be able to accelerate the particle at a rapid speed. And so this was first built around the border of France and Switzerland. And so when this was being built, people were having all sorts of doomsday reactions and saying that the world was going to explode as a result of this. Well, after this was done, and this experiment was finally done, we're all still here. The world hasn't blown up yet. And they were able to conclude, well, they did this hypothesis testing basically. And so their hypothesis was that this Higgs boson or this God particle does not exist. And this ended up being their null hypothesis. So their null hypothesis was that the God particle does not exist. So what did they do? Basically, they assumed the null hypothesis was correct. God particle does not exist. And then they took their observations that they actually observed from this particle accelerator, and they looked at where their observation was relative to this distribution. And then they saw that their observation was very far to the right of this distribution. And their z-score ended up being something like 7. So just like we said in the previous example, if the z-score of the observation is very high, something like 7, then it's likely to be in the tail, regardless of what confidence level you use. And it turns out that in science, the gold standard is that z-critical should be at least 5 standard deviations away from the mean. So z-critical in science, the gold standard is considered to be 5 standard deviations. So z-critical is at 5, but they had an observation whose z-score was 7. So that means it's definitely in the tail of the distribution. And we said that if the observation is in the tail of the distribution, then that means that we can go ahead and reject the null hypothesis. So that means that based on the observations they actually observed, they were able to reject this null hypothesis that the God particle existed. And therefore, they have to accept the alternative hypothesis that the God particle does exist. And again, we're not saying, this is just a phrase that was coined by the media. This is just this particular specific type of particle. The conclusion is not implying that God exists. It's just saying that this particular God particle exists. Any questions? Okay, and so to reinforce what we talked about, if we have this observation that has a z-score of 7, that means the p-value is around what?
0.
Yeah, very good. So around 0, just like in the previous example. That means if you calculate this area to the right, or on one side of this z-score, then it's going to be approximately 0. So if the p-value is 0, again, what does that mean? That means that if the null hypothesis were correct, and this Higgs boson particle or God particle doesn't exist, then the probability or chances that we actually observed what we just observed is 0. But if the probability is 0, how did we just observe it? So there's that contradiction. So therefore, this null hypothesis that we're assuming to be true can't be true. And so this null hypothesis that the God particle doesn't exist can't be true, and therefore the God particle must exist. And so that's what the scientists ended up concluding. And really, all science is based on this framework of hypothesis testing. You have this hypothesis, and either you can reject it, or you can continue to hold on to it and not reject it. Any questions?